Welcome everyone. Thank you for joining us today for BigRep's virtual demo. We're so happy that you could join us today, and we really wish that we could all be together in person. But since we can't, we're going to take the next best approach, and we're going to bring you our printers to you live today virtually. Who is BigRep, you might be asking? And BigRep is the leader in large format additive 3D printers. We are German engineered. And our printer is the one that you can see in the screen there is our one that's kind of our flagship printer, and that is 1 meter cubed. The other printer that Chris will walk through is a G2, and a G2 is half the build size there, and it can actually fit 10 desktop printers in it. So just to kind of put things into perspective, the one we figured out can actually fit 2 baby elephants in it. So it's that big. And not standing next to it, it's kind of hard to grasp how big that really is. But BigRep printers provide engineers, designers, and manufacturers with a solution to efficiently produce functional prototypes, jigs, fixtures, patterns and molds, and also end-use parts. So with that, as you can see below me, we have a great partner with us today, Monotech, and so I will let Rajesh introduce himself.
Hi, thanks, Abbey, and hi, everybody. This is Rajesh here from Monotech Systems Ltd. I'm the Vice President for 3D Products and Solutions. And Monotech is a 22-year-old company, and we have been investing in 2D and 3D print solutions for the last 22 years. And since 6 years, we are in 3D printing, additive manufacturing, and we have a whole range of technologies with us. But most of the technologies which we have are all printing small. And with BigRep, we print big, and that's what we are looking for, because our main focus is on manufacturing segments where a lot of casting, patterns, and a lot of jigs, fixtures, and the large components are to be made. So with BigRep and with the materials which is being provided from BigRep, we are able to get large parts, very tough parts with good repeatability, and German engineering, of course, is helping it. So we are proud to be partners for for BigRep since 4 years now. Thank you, Abbey. Over to you.
Thanks, Rajesh. We're glad to have you a part of the BigRep family. Just a quick question while I see Chris walking around getting ready there to you. What does large really mean to your customers? I know you mentioned, that you have a lot of other smaller parts, but what does large really mean, and what benefits do you see it bringing to your customers?
So when we talk about prototyping, it's normally scaled down parts. So people are talking about scaling down your parts. Large means one-to-one, and in the scale, there's full-scale parts which are being printed, and they can actually use it for the end purpose, what they're talking about. So large means a lot for people. I think there are many small parts which are also important, but large is really, really important for manufacturing industries.
Great. Yeah, and I know Chris will show some good examples as well. So Chris, if you are ready there in Boston, let's go live there and check out the first printer.
Great, let's do it. So thank you, Abby. Thank you, Rajesh, for the introduction. My name is Christopher Lee. I'm an application engineer and technician from BigRep. I am in our tech office just outside of Boston, Massachusetts. As Abby mentioned, we'll go through 3 machines, the BigRep 1, the Studio G2, and the BigRep Pro. It's live, keeping it as an open conversation. If there's anything that I mentioned or you may look at, want more information on, or anything like that, please put those questions in the chat. Abby will be happy to relay those to me to make sure you guys get the most out of this demonstration and know the full capabilities of our printers. So the first one we'll go through is the BigRep 1. The reason why we call it the BigRep 1 is due to its build volume of 1 cubic meter, or 40 inches X, Y, and Z. So a bit about BigRep. We've been around for 8 years, a little over 8 years, 500 plus customers. The BigRep 1 was our flagship machine when BigRep first started. Since then, it's gone through various upgrades and design changes to now what you see here. With the extremely large build volume, you have dual extrusion capabilities, you have nanotech step motors, a heated bed, all that good stuff. So specifically on the extruders, we offer what are called power extruders. The power extruders allow for a range of nozzle sizes. So depending on the type of quality and speed that you're looking for. So in this case, for this print, we wanted to go a little bit faster. The quality wasn't the highest priority, it was the overall throughput. So we used a 1 millimeter nozzle. If we wanted to go even faster, we could swap over to a 2 millimeter nozzle. And if we wanted to go a little bit slower, but have the part look a lot better, reduce post-processing, then we could use a 0.6 hot end. So those hot ends are brass hot ends. So all of your materials are your low-grade engineering materials and your standard polymers like PLA, PETG. We also have some water solubles. So the bed is 1/4-inch aluminum with a sheet of polyamide on top, or a Kapton film. The bed can get upwards of 80°C. And then with the Kapton film, what that allows for is a couple different things. First, it distributes temperature well, so there's no cold spots along the bed. And then secondly, with the materials that BigRep offers, it does increase adhesion, especially for these larger, wider parts. You don't want things warping up or shifting on the bed. So that's what that Kapton film does. Outside of the extruders and the bed, the main concern for large builds is maintaining quality in the Z-axis. So you can see large spindles, guide shafts, and then we're using these Monotech stepper motors and a belt-driven system to create a reliable, repeatable action so that we can take parts from the CAD data, slice them in our software, and then get parts plus or minus 20 microns in the Z, and then plus or minus 100 microns in the X and Y axis. So with the dual extrusion capabilities, and I'm going to take a walk towards the back of the machine, we can go into the actual material itself. So the material used, it is 2.85 millimeter strand filament on spools. So we sell spools anywhere from 2.3 kilograms to 8 kilograms. The materials I mentioned, PLA, PETG, we have a non-toxic ABS called ProHT, you know, food safe, medical grade, all of that. So BigRep as a company has come out with at least a dozen of our own materials, but we do trust in the hardware of the machinery and offer an open material platform. I know some competitors, they are a bit limiting on the materials that can and cannot be used. For us, as long as it's 2.85 millimeter filament, the machine doesn't care, and you'll have the technical support from BigRep, from your reseller, to create the process settings to ensure that whatever material you want to run will run well on the BigRep. So some other smaller features, but important features with large format, out-of-filament monitoring. So there is a sensor up on top there that Amnon is showing, and there's also a sensor inside the extruder that when material is no longer present, it will initiate a pause sequence during the print that will stop heat on the extruder, raise the gantry, and allow users to resume the job after they fill in new material. And nothing happened, because for longer and longer prints, you want to make sure that it is savable after running out of filament, and even after a power outage or the machine stops, whatever it may be. The machine does have the information stored to restart after a power outage. So, for example, if the machine's off, upon rebooting it towards the user interface, it will prompt you with the option to resume the job. the machine will know to go all the way up in the Z-axis, go all the way back down, and then resume where it just ended off. So obviously the worst feeling in the world is to have a 7-day print, lose it 5 days through, but with these features, we don't get that as often. So a little bit more on the user interface. So the PC panel is Linux-based, if you are familiar with those types of software. Very user-friendly, very easy to follow. File upload, obviously you're gonna take a G-code. You can do it via direct USB plugin, or if you have the machine connected to Ethernet, you can upload it remotely. With that Ethernet connection, you can upload the files, you can preheat the bed and the hot ends. You can stop the job. The only thing you can't do, just due to general safety restrictions, is start it remotely. So a bit more on the user interface. So you can see here, tool 0, tool 1, that is just what we call each extruder head. The bed is at 60 now because we're running our Pro HT, which is that non-toxic ABS. You can control the XYZ motion when it's not printing. You have your terminal for any specific codes you want to input, and then you have your advanced tab for calibration. I know that was a lot all at once. Abby, any questions so far from the audience?
Yeah, we're starting to get a few come in, but maybe before I ask some of those, could you maybe walk through what happens during installation and any maintenance that the machine typically requires?
Yep, so installation can be virtual or in person. Installation usually takes 2 days for hardware training, and then a 3rd day for software training and some other questions that may come up. During installation, we'll go through leveling the gantry, leveling the bed, calibrating the extruders, and then making sure the end user is more than confident in doing what we do. Obviously, once the installation is done, that doesn't mean we're done working with you. We'll go through iterative trainings on software and hardware, whatever it may be, to make sure you are comfortable with running the machine and happy with the quality. So with any machine, it does come with 12 months free warranty. So that includes all spare parts. I believe it's a site visit. The only thing it does not include are 2 consumable items. One is the Kapton film, and then the other is the hot ends in the power extruders.
All right, good. One question came in, can it do mirror printing?
Yep, so there is an option. Normal setup, you have one extruder next to each other. We offer a tandem mode, which I think is what he or she's talking about with the mirror mode, where you'll have one extruder on one side, and then the other one will be offset by about 300 millimeters. It will cut the bed in half in the x-axis, but whatever is printing on the left side, it will mimic it on the other side. So it's doubling your throughput, assuming the parts are now half the size in one axis. So that's an added accessory if you want to do that, and that would be installed by a BigRep technician.
Okay, great. How much material, since it's big parts, how much material can one of your spools hold, or can the printer hold?
Yep, so there are 2 holders in the back. So if it's BigRep material, it can be upwards of 16 kilograms. I have seen customers bring in third-party materials. They would set up their own table. I think it was a 25 kilogram spool. So obviously they were printing a very large part and they need that extra material. So it's really up to the end user, and it is pretty flexible on the size of the spools and overall weight.
All right, another good question just came in. Can you enclose it?
Yep. So If you want it BigRep enclosed, I'll show you the next machine. If you want it just a basic enclosure, we do have accessories for that as well. I know some customers, if they're in a metal shop or a woodworking shop, they use it as a physical barrier to prevent that stuff from clogging the nozzles. Some customers, it can be a safety issue. They don't want people with the ability to stick their hand in. So we do have options with interlock switches, all that safety stuff to prevent that from happening. So yes, we can enclose it.
Very good. And my favorite question to ask you before we move to the next printer, what's the biggest part you've printed on the one?
Biggest part, I think it was 3 or 4 weeks, just a very, very, very large mold. Took myself and Amnon, our operations manager, all of our effort to get it off the bed, because we use extra adhesive on the bed as well, which I'll get into in a little bit. Between the adhesive and the Kapton film, things stick very well. We do have some basic methods to release it from the bed afterwards. To be honest, I'd rather have it stick too well to the bed as to not well enough, just to maintain the quality. And then we can put a little bit of elbow grease in the end to get it off the bed.
All right, good. That is all the questions that we had on the one. On to the next.
On to the next one. So next one, let's do the baby of the bunch, the Studio G2. So this, as Abby mentioned, is half the build size of the BigRep 1. So on the X, it's 1,000 millimeters. In the Y, it's 500. And then in the Z, it is also 500. So big difference between the 1 and the G2. G2 is fully enclosed. That does allow for a wider range of materials that I'll get into shortly. Inside of the chamber, instead of a 2 independent extruders, there is a single extruder head with 2 independent nozzles inside. So even though it's a single piece here, it is still offering the dual extrusion capabilities like the BigRep 1. The G2 by default uses 0.6 millimeter hot ends. Those can be brass, and those could also be hardened steel depending on the materials that you want to run. If you're running a hardened steel nozzle, you can use carbon fiber materials, nylon, ASA, ABS. With that full enclosed, you're getting that mid-grade engineering material portfolio available, something that you can't necessarily do on the one because of the required heat, because of the warping of some materials. This makes it a lot easier for you just to deal with those trickier materials. So 1/4-inch aluminum for the bed, tapped on top, just like the BigRep 1. The bed here, you can get upwards of 100 C. The nozzles are upwards of 300 C. And then similar gantry system with the belts and the Monotech stepper motors. The extruder here is less heavy than the BigRep 1 extruders. So because of that, we're able to go a little bit faster in the millimeter per second range, because it's able to deal with those vibrations a little bit easier. And with the smaller hot ends, because we're physically extruding less material per layer, we're able to really crank up the speeds in that way. Obviously, it's a little bit relative. A 1 mil hot end printing at a certain speed, maybe it's a little bit slower, but because you're extruding more material, there are benefits to each option. So as I said, the 0.6 default, you do have the ability to swap it out. It just wouldn't be a BigRep certified hot end, but we have had customers do that in the past, just based on the applications and throughput that they're looking for. So the G2, as well as the one, they do come with onboard cameras just to monitor all the fun stuff that's happening in the build chamber. that can be accessed once the machine is on Ethernet connection. And then with all of this extra heat that's in the chamber, we need to figure out a way to control it. So on the upper end of the print chamber, a little hard to see from Amnon's angle, there is a fan that is pushing out any hot air past a certain point. That temperature and that hot air is controlled by a few temperature sensors down underneath. If you know, that's a good look. So those temperature sensors down here, one controls the print chamber, and then the other two control the filament chambers. So trickier materials require a bit more pre-treatment compared to like your PLA. So on the bottom here, we have two insulated filament chambers that are independently heated. So right now we have a CF material with a water soluble support. The CF material and the soluble support have different drying temperatures and times. The water soluble support likes moisture. It does have quality issues if it's open to the environment for a while and it's not dried out. So with this heating, I believe we have it at 30, 32 C. We'll dry this for an hour or two before printing and keep it dried while printing. This will alleviate any quality issues and make sure that the material is printing well and consistent all the way through. And during installation, calibration, the technicians, resellers, they'll go through the breakdown of our materials, how to handle them, how to treat them, all that good stuff. So again, the goal of it is to have the end users be fully confident in what we do on the day-to-day. And I think we do a very good job in that. And you know, all of our customers are printing a lot with these machines and having very good results on a day-to-day basis. Yep. So this was printed on the G2 here. This is a manifold that we use for print samples and sales kits and things like that. So this type of quality and throughput is quite good for the G2 and the 06 hot ends. And specifically on the G2, obviously it is a very large build volume, but that doesn't mean we're limiting ourselves to just large parts. A lot of our customers, they would print a lot of little parts. So in our slicing software, which we'll get into afterwards, you have the ability to set up batch printing, where you can do all at once, having them print, or you can do it mixed mode, where you'll have a batch here, print, batch here, print, batch, batch. So by the end of it, you'll have 40 something pieces, and you know, you'll pick off 5 at a time. And if you're running for you know, inline manufacturing, you need that constant upkeep, that constant you know, parts coming off of the bed, and that would be a viable solution for something like that. Okay. Abby, anything regarding the G2?
Yeah, I got a couple questions. A couple on materials. What's the material range it can print? And then one is, can it do carbon fiber?
Yep. So material range is your mid-grade engineering materials all the way back down to your standard polymers like PLA, PETG, things like that. So temperature wise, like I said, 100 C on the bed, 300 C on the extruders. So you're not going to get things like ultimate peak, but basically everything else underneath that we have worked with and we have printed on the G2. And to your question, carbon fiber, yes.
Good. Great question here. Do the printers come fully assembled?
Pretty much, yeah. On the one, there's some minor assembly work in the back, but it's just for the filament chamber. But what you see here, we'll put it in a box, ship it your way, and that's what you get.
Great. How often do you have to replace the nozzles?
So the nozzles, a couple of different factors that go into their lifespan. One is the material. If you're running a glass-filled chopped nylon, that would decrease the lifespan compared to a nozzle that was running with a PLA. Just the abrasiveness of certain materials can eat away at the insides a little bit. So if you're running a carbon fiber, 24/7, I would say it's about 6 months to a year for that hot end. And then if you're running a more basic material, we've had machines here with the same hot ends running for a year and a half, 2 years.
Good. Hope this doesn't happen very often, but one question did come in about power outage and what happens to your build. Is it a loss?
Nope. So during installation, we calibrate the Z-axis in the software to semi-automatically resume after a power outage. So power's dead. We'll turn it back on the user interface. It will give you a little prompt to resume your last G code. You hit yes, it'll tell you to preheat everything. Once everything is preheated, as long as you're not moving the gantry in the XY axis from where it stopped, it will go all the way up in the Z axis, count how many steps it takes to get to the top, go all the way back down, and then resume from that most recent XY position, and nothing's lost.
Well, that's awesome. Especially if it was, mid couple week build. Okay, that's all the questions I've got on the G2. Should we head over to the Pro?
Yeah, let's do it. Okay. So the BigRep Pro is the newest machine that we've come out with. Same build volume as the BigRep 1 meter cubed, but it has all the bells and whistles of a G2 plus a lot of other cool stuff that we'll get into. So bed 100C like the G2. The extruders are a little bit different compared to the G2 and the 1. We have 2 types of extruders that we offer to customers. The setup that we have here is the ACE extruder. And then we also have what is called an MXT extruder. The main difference, ACE extruder is your more standard FDM technology extruder. This has the widest range of material options, similar to the G2 printer. The speeds, I think, are still above average compared to other industrial printers. And the MXT, new type of extrusion technology. With that, the materials are a bit more limited, but for those materials that it can run, it goes a lot faster than your ACE extruder. So obviously, because we have to go a lot faster, it takes a little bit more time to develop materials for that extruder, which is why we have both options. So a common setup is customers will have an MXT extruder on one side for the higher throughput jobs, the materials and the applications where they need a lot of parts. And then the ACE extruder could be used for more unique applications with newer materials and things like that. So for our case here, because we're running benchmark parts and print services, we like the ACE extruders just because we have a wider variety of materials that we're running on the day-to-day. So it just makes it easier for us. With the extruders, the MXT and the ACE, we are pairing it with high-end CNC controllers through Bosch Rexroth. So with the control system, with the new extrusion technology, with MXT, we're getting really fast speeds, high throughput, and with the controllers, it's that required repeatability. With each print, we're able to generate millions of points of data and then verify that data to understand a set specification. So data points, they could be XY locations on the bed. They could be temperatures, it could be flow rates, it could be fan speeds, whatever you're looking for. To where if you're printing 20 parts on the bed, 19 of them look amazing, the 20th is just okay. We can go back to the timestamp, check out what's going on. Maybe an XY location was off a little bit, maybe it was something else, whatever it is. We have that data to then go back to our process settings, to our slicing software, make a little bit of tweaks, improve it. So next time, 20 out of 20 of those parts are excellent. Now you'll see up on front, onboard camera, same as the G2 and the 1. So controllers here for the X, Y, and Z, belt driven, just like the G2 and the 1. Again, looking for the hardcore German engineering, giant spindles, giant lead screws. You need that consistency from layer 1 to layer 5000. And with all of this engineering that's been put into it, we've really hit a home run with the Pro. So we'll take a little walk towards the back of the machine. Like the G2, running some trickier materials that require some pre-treatment. So for this guy here, for the Pro, we have the insulated filament chamber. So you'll have the dry packs here, and then you'll have the roller that it'll sit on, feed through into the extruder, and all that stuff. Yes, that's just more dry stuff, just to make sure moisture is kept out. Moisture is no good for 3D printing, so what it's there for. Give you a quick little look into the electronics and hardware that go into the control system. So normally you see this stuff on high-end CNC systems, 5-axis milling machines, but now it's on a large 3D printer. And I think at this point, we're even just starting to maximize the capabilities of the Rexroth system in our new MXT extruders. So right now we're probably 1.5, 2 times the speed of our competitors using the MXT extruder. And I think in the near future, this is built to be upgradable, customizable for customers. And as we learn more and more, we'll get even faster, even better quality, even more throughput on this machine. So up on top there is just your little pilot light. It's yellow. It's kind of mad at us because the doors are open. Once we close the doors, lock them up, we'll get the green means go and get a print going.
Chris, as you're kind of walking around there, what's the footprint? I see the doors open, you had the doors in the back. Like, what's the footprint that you would need in a facility to house the Pro?
So the doors are about 3/4 of a meter long. In the X, about 6 feet. Same in the Z axis. So I'm 6 feet tall. Put that into perspective. And then back in the Y, it's about 8 feet. And then we offer, or require the service area for the doors so you can remove parts, and then a little bit of room in the back for the electrical cabinet. So one thing unique to the Pro is the operating system. The BigRep 1 and the G2 are Linux-based. BigRep Pro is Windows-based, which makes it a lot easier for remote access from our software guys. If we need to run any diagnostics or software upgrades, very simple application where they would just remote into the system. They do everything behind the scenes and it's all taken care of in 5 minutes. And just like the other guys, once it's on Ethernet, you have the camera access. You can upload via USB or remote upload of the files. Again, it's all G code. So yeah. Yeah. So MXT versus ACE. So let's start with this guy here. This was printed on an ACE extruder. I want to say a 0.4 layer height. That took about 16 to 20 hours. So very good part, good looking part. And then this guy here was printed on a MXT extruder, same layer height, same everything, but this took 9 hours.
4 hours, 9.
Oh, gotcha, that one. Sorry about that. That took 4 hours compared to the 16 hours on the ACE extruder, and this is in a nylon material, where this is in a ABS-like material. So depending on the throughput quality that you're looking for, we have both options, so it's up to you to decide what you like.
I just got a question on that. How easy is it to swap between the two extruders?
Quite easy. There's a couple thumb screws back here, a couple cables in the back. You know, with the machine off, I can have it swapped over in under 5 minutes. And then if you're running dual extrusion between MXT and ACE, there are some calibration files that are embedded in the software that take half an hour to run. And then you're good to go.
I think you maybe mentioned this, but just clarification, what materials can the ACE do? And same question again, can it do carbon fiber?
So the ACE material throughput is the same as the G2. Fiber ready extruders. So yes, it can do carbon fiber. Pretty much, yeah, again, same as the G2. Same temperature, 100 C on the bed, 300 C on the extruder. Same open material platform. So if you want bigger materials, sure. If you want third-party materials, as long as they're within the same temperature range, works just fine. The MXT is just a little limited to that right now. It's nylon, it's ASA, and then we'll have more materials coming as we grow with the MXT technology.
All right, great. I don't have any more questions on the Pro that came in.
So, Abbey?
Yes.
So Chris will go to his blade to show the blade.
Okay.
And if there are any more questions, I will look at show some models.
Great. Yeah, so maybe as Amnan's walking here, he can talk through some of the parts that we've got here in the office, some of our demo parts, but also you can see the wide range too of post-processing that can be done to the parts once they're done too.
Exactly. This is the part for that we want to show in a demo, that you basically can do a lot of post-processing, where you can send it and color it and do whatever you like. So this is something that we show in some of the shows. Here we have a bicycle where we use the TPU material to print these tires. Also, there is another table with crazy geometry that we print on our printers. And if we're looking here, I don't know if anybody saw our a motorcycle that we actually print fully motorcycle, but this is one of the tire that we use. Also, you can plated parts if you read it. So it's metal plated. So basically, you can do whatever you like. We have one customer that asked to do some crazy wall that for some cubicle things. Some customer printing trees. Just it's amazing what people creatively creating here. So basically, you can print anything you want on the machine.
All right. Maybe, Chris, are you all set?
Yeah, can you hear me okay?
Yep. And maybe too, as you're kind of, let me switch the spotlight here. There we go. Yeah, maybe as you talk too, you could talk a little bit. We just got a few questions after Amnon's little tour there about support removal and support material. So maybe as you're getting set up, you could quick touch on that too.
Yeah, so support material in most cases is our EVOH, the water soluble support. So when we're removing that support material, we try and physically remove as much as possible using pliers or whatever it may be. And then we have a dunk tank, a little sink in our office that is used to remove the remaining material. And once it's fully dissolved, you'll have a nice smooth under surface where that support material and the main material met. If you want to make it a little bit faster, there are materials that offer a single extrusion option where it's the part as well as the support, where it functions as a breakaway. Anything else before I jump into blade?
Nope, sorry, I couldn't get unmuted there. No, good to go.
Okay, good. Okay, so this is BigRep Blade. You can download Blade directly from our BigRep website. If you've ever used Cura in the past, this is essentially that with a little bit of BigRep functionality behind it for large format. If you're running the G2 or the 1, it doesn't have to be on Blade. If you're running the Pro, because of the MXT technology, it needs to be on Blade. So just to keep that in mind. Once you have your Blade downloaded, you got to figure out which machine you're working with. So we have the 1, the G2, the G1, as well as the Pro. In this case, I just have it on a G2. I uploaded my part, hitting the little folder button here. And then once I have my file in place, what it will do is automatically orient it to best fit on the build. If I want to do that again, it is under extensions, auto orientation, and it'll just place it where it needs to. So that auto orientation feature is there to minimize job time and support material. Obviously, if I was printing something like this, there would be some overhangs underneath and some extra support material, and it just wouldn't be ideal for something as simple as this. So Blade makes it easy for customers and does all the guesswork for you to keep that job time as quick as possible. Once I have it in place, so I guess just for orientation's sake, your doors are on this face here, so you're looking directly into the plate there. I'll put it over here just because. Next is figuring out the material setup that I want. You can choose between T0 and T1. For this one, I'll have it on T0. My material will be Pro HT, which is our ABS, and then my hot end is just the standard 0.6. Once I have that set up, I can use one of the BigRep profiles. Let's take a look. Because I'm running single extruder, I'm gonna make it kind of easy for myself and disable the other extruder. So everything is on T0 and I'm not gonna have any funky overlaps between settings. And so with these profiles, I have a couple of different options based on a visual setting or a default setting, which doesn't go as fast, but you know, you'll get the better look here. This will go faster throughput. And then the layer height determines your overall print time and required post-processing. So for something like this, it's a simple part, a little bit of curvature angles over here. So I'll keep it at a default 0.3. If I wanted this to look, you know, super amazing, then I would drop this down to a 0.2 or a 0.1. Do I need a visual? Probably not for something like this. So right now, everything looks to be okay. I'll give it a quick run through and actually slice it, see how long it'll take. So 2.5 hours, it gives me the weight of the material, the length, you know, and the 2.85 spool, and then it gives me the material breakdown based on the weight here. I can go up top next to prepare and check preview, and I can see what's going on by a color scheme, line type, and I can scroll through each layer, see what's going on, see if it makes sense. If I'm happy with it, I can save the file either on my USB if I want to bring it to the machine, or I can upload it to our web page and send it to the machine that way. I mentioned earlier batch printing. If I highlight it, go to extensions, and then I can populate the build plate for sequential printing, it will think a little bit and do it this way. So under special modes, there's a mixed mode as well as a all at once. So I'll do the all at once first. So depending on the size of the model, that can vary the slicing time. This model here is fairly small, but as I bring in more and more iterations of that model, that will increase the slice time a little bit. It's just the number of triangles that make up the STL that increase the size. And so 12 hours for 5 units with my option as all at once. When I'm scrolling down here, it's jumping from one to the next for each layer. If you think about it, this really isn't the best option. You know, if you run out of material or something bad happens on rare occasion, you would lose all 5 of them because not a single one has finished by the time you hit these layers. If I go to mixed mode, we'll check out the difference. And then one other thing with the all at once, it's a lot of travel motion because you have to travel from one side to the next, to the middle, to the back and forth. It's just a lot of wasted movement for the printer. So using mixed mode, you'll notice as I scroll through the layers, it is doing one at a time, which reduces the travel, which increases our capabilities of throughput in a sense. You know, if you need one at a time, you're able to do that. Grab it from the machine as the other prints are finishing up. It's my personal preference for something like that. The reason why it's staggered in the x-axis and not the y-axis is because of the gantry. The gantry is in the y-axis, and if I were to print a model here all the way and try and print another one right next to it, it just wouldn't work. So if I do Control M just to multiply, and I put this in the same Y plane as this guy, Blade is smart enough to actually group them together, and you'll see once it finishes slicing. Any questions so far, Abby, on the Blade software?
Yeah, so one asked about support generation. I know this part doesn't need it, but does Blade do that, or do you
Yep.
need another software?
Yep, so we'll get into that real quick. So with this one, it's doing these guys normal, and then it's actually grouping these two together because it knows the staggering and the offset required for each part. So it's smart. It's really good for the batch printing, and it's always something we highlight during demos and stuff like that. So for support material, let's orient this in a silly way that it will generate support. Anytime you see a red surface, that is telling you Blade is making support. I slice it. So before it was, I think, 2 hours, 2.5 hours, and now it's 4 hours because it's generating all of this extra support. We have the option to generate our own support if we want to, as well as reduce support in some areas. It's more of an advanced feature, which we can get into offline, but it is possible to idealize your part. If you know it doesn't need support, or if you know it needs more support, we have that capability on Blade. How are we doing on time, Abby, and things like that?
Yeah, maybe one more minute here to wrap up Blade.
Okay, sure. So if you're running dual extrusion, so maybe I want to print this in a CF material. So engineering, high temp CF, discard that. I'll enable my secondary extruder and have it with the water soluble support. Put my support material on the T1 extruder. You'll see this little gray circle pop up. This is our prime tower. Excuse me. The prime tower is used to purge out material whenever you're switching from layer to layer. If you don't have the prime tower, the quality will not be as good. If you're changing it on the fly for this part here, just you'll see this with any FDM printer. If there is a idle time when you're swapping between materials, when you're resuming that other hot end, it won't be fully extruding, 100% when you first start. So we use this prime tower as a bit of a buffer period to get it printing well, nice and smooth before it actually starts here. Obviously it is wasted material, but that wasted material is well worth the quality increase of your end part. If we're looking at batch printing and stuff like that, because we're running a prime tower, it cannot do that. So the batch printing is only for single extrusion jobs. I think we're working on it for dual extrusion, but it's just not available yet. So like the rest of them, you can go through the layers and see what's going on. In this case, color scheme is material color. So the black is your high temp carbon fiber, and the white is the BBH. That's all I got.
All right, great. Well, that was some impressive demos there. Rajesh, you've had a chance to take it all in here. Any thoughts on the BigRep printers?
Yeah, absolutely. And we have been using the BigRep 1 for many years now, and it's been one of the most stable printers we have ever seen in the world. And I've seen a lot of printers, but what stands apart is the MXT technology of Pro, and of course G2, which is the next generation of the Studio, and the type of materials which it can do. I really am excited to look forward, to have a Pro, with us and print manufacturing parts. It's a great technology which is really standing apart now.
And what do you see as your customers for the biggest benefit of BigRep printers? What value do they really get from the printers?
Yeah, so we have been working with a lot of customers, right from aerospace, defense, automotive, architecture. We do also work with a few signage partners, signage customers, and the value which they get is basically the large printers, large print platform, large parts, and really tough and repeatable parts, and that's what it shows out. And the finish of the parts are quite outstanding. I mean, we have seen out of Pro HT and few other materials the type of finish which we get and the repeatability is outstanding. That's what our customers also look for.
Great. I think that is a great way to wrap up this virtual demo here. I do also want to throw out there, though, that if you guys have challenges, if you have parts, if you want to see what your part could look like on a BigRep, please feel free to reach out to Rajesh, reach out to us as well. We'd be happy to take a look at your part and blade, give you some estimates on material usage, time to print, things like that. More than happy to help you out with that. So with that, I hope you all enjoyed the virtual demo today. And until we can all be together again, stay safe, stay healthy, and go BigRep. Bye, everyone.